College Trigonometry, Chapter 8, Section 6, Evaluating Trigonometric Functions. Okay, so we have an acute angle, angle A, and we've drawn it in standard position. And going back to our geometry days, we have created a right triangle, and then we have used SOHCAHTOA to determine sine, cosine, tangent, and all of those. So we've got sine is y over r, which is opposite of our hypotenuse, cosine is x over r, and so forth. So using our knowledge of sine, cosine, tangent based on geometry, find the values of sine, cosine, and tangent in this right triangle. Remember, you're just going to get ratios, fractions, and leave them that way. So find the sine of A, the cosine of A, and the tangent of A. Pause the recording, give it a try, and resume to check your answer. So, opposite would be 7, adjacent is 24, and the hypotenuse is always the side across from the right angle, which is 25. That gives us a sine of 7 over 25, a cosine of 24 over 25, and a tangent of 7 over 24. Now, some angles that deserve special attention are the 30 degree, 45 degree, and 60 degree. In geometry, you study these as special angles, and they are still special. They're very common angles, and here are the triangles that we use for them. The 30, 60, 90 right triangle, the side opposite the 30 degree angle had a side length of 1. The hypotenuse has a side length of 2, and the longer of the two legs, square root of 3. The 45, 45, 90 triangle is an isosceles right triangle. The two legs are equal sides, so we put a 1 there, and then the hypotenuse is going to be the square root of 2. And this is a chart that shows the sine, the cosine, the tangent, the cotangent, the secant, and the cosecant for those three special angles, as well as their equivalents in radians. Now, in a triangle ABC with a right angle of A and acute angles A and B are going to be complementary. In other words, they total 90. We also notice that the sine of angle A is A over C, which just happens to be the cosine of B. The tangent of A is A over B, which is the cotangent of B. The secant of A is C over B, and that happens to be the cosecant of angle B. Since angles A and B are complementary, and the sine of A equals the cosine of B, the functions sine and cosine are called cofunctions. So if you ever wondered why cosine, why cotangent, why cosecant, the co stands for complements. Okay, so the complementary angles are going to have the same sine and cosine. Okay, this is true for secant and cosecant, tangent and cotangent. So that gives us some formulas, and I do believe these are on your formula sheet. If A is an acute angle measured in degrees, then the sine of angle A is the cosine of 90 degrees minus angle A. In other words, the cosine of the complement. And you see it spelled out for all 6 trig functions there in degrees. If we're talking radians, instead of subtracting 90 minus the angle, we're going to do pi over 2 minus the angle. And you see it spelled out there for all 6. If you need to pause the recording while you study this, go ahead. If not, we'll continue on. Let's do this example. You're going to write each expression in terms of its cofunction. Pause the recording, give this a try, and resume to check your answer. So all you needed to do here was to, for A, do 90 minus 52 degrees 16 minutes. So instead of cosine 52 degrees 16 minutes, you're going to have sine of 90 minus that. And when you subtract, you get the sine of 37 degrees 44 minutes. For the tangent of pi over 6, since this is in radians, it'll be the cotangent of pi over 2 minus pi over 6. And when you simplify that, you get cotangent of pi over 3. Here we have a chart. We're going to talk about reference angles for a minute. A reference angle for an angle, theta, written theta prime, is the positive acute angle that is made by the terminal side of angle theta and the x-axis. So when we talk about reference angles, what you're going to do is take the angle they give you and you're going to go to the terminal side and you're going to look at the angle made by the terminal side and the closest part of the x-axis to it. So in quadrant 1, theta and theta prime are both going to be the same angle. But you can see here we've got in quadrant 2, you see where theta is in the green, and then theta prime is between the blue terminal side and the negative part of the x-axis. And how you determine the measurement of theta prime for quadrant 2, and again this is in degrees, will be 180 degrees, which is the entire half circle, minus theta, and that leaves you with theta prime. Quadrant 3, you're going to have to do the angle, which goes all the way to the blue line, minus 180, and that will leave you with theta prime. And then finally for quadrant 4, you'll do 360 degrees, the entire circle, minus theta, and that leaves you with theta prime. Now, this is for angles that are between 0 and 360 degrees. If the angle is negative or greater than 360, then what you have to do first is you need to find the coterminal angle for that is between 0 and 360, and then you use these techniques that's shown on the chart here. Reference angle for each angle given. Pause the recording, give this a try, and resume to check your answer. It's helpful to do a drawing for these. I like to do that myself. So you have a 218 degree angle. You'll notice that goes past 180. So to find the angle between the terminal side and the x-axis, we're going to do 218 minus 180, and that leaves us with 38 degrees. Similarly for B, we need to do this in terms of radians. 5 pi over 6 doesn't quite go to pi over 2, so I'm going to do, or to pi, excuse me. So I'm going to do pi minus 5 pi over 6, and that gives me the reference angle of pi over 6. Now find the values of the trigonometric functions for 210 degrees. Find the reference angle first, and then give the values for the functions. Pause this recording, give it a try, and resume to check your answer. Okay, the reference angle is going to be 30 degrees, as you see here. And 30 degree angle is very familiar. That's the 1, 2 square root of 3 triangle. So you could probably just go in and put the measurements in there. So you can choose a point on the terminal side and make that distance 2, and then put in your 1 and your square root of 3. Now notice your y value, your x value will be negative. We're in quadrant 3, so everything but tangent and cotangent are going to be negative here. And here you see the values of the 6 trig functions for 210 degrees. Okay, so here's a procedure for finding the trig function values for any non-quadrantal angle. And again, we're talking about angles where the terminal side is not on an axis. If the angle is greater than 360 or less than 0, then you're going to find a coterminal angle by adding or subtracting 360 as many times as needed to obtain an angle that is between 0 and 360. If we're dealing with radians, then we're going to use, obviously, 0 to 2 pi, and just convert everything for radians there. Then you're going to find the reference angle, and then find the trig function values for the reference angle. And then you want to make sure you have the correct values, correct signs for those values. And you can do that either by using the graph to help you, or the fact of what quadrant the angle is lying in to help you figure out the signs for those. So find the exact value of each expression. Pause the recording, give this a try, and resume to check your answer. So negative 240 degrees would be coterminal with 120, which gives us a reference angle of 60 degrees. So we have a 30, 60, 90 triangle, and the cosine of 60 degrees is 1/2. This lies in quadrant 2, so it'll be negative 1/2. Tangent of 675, the coterminal angle is going to be 315 for that. Get that by subtracting 360. The reference angle for 315 degrees is the tangent of, it's going to be 45 degrees. It is in quadrant 4, which means the tangent will be negative, and so we get -1. Okay, now you're going to use your calculator to approximate the value of each expression. So pause the recording, give this a try, and resume to check your answer. And you should have made sure your calculator was in degree mode, although I will say this, if you are in radian mode and you don't want to change it, using the degree symbol in the angle menu will override the mode that it's in. So like if you put in A as it is written there and you are in radian mode, it will still give you the right answer. For B, what you would need to do is 1 over sine 197.977 and put a degree there, and then it doesn't matter what mode you're in, it will automatically do it in degrees for you. So you can do that to keep from switching back and forth if you want to. Sometimes we know the value of the trig function, we know the sine or we know the cosine, but we need to know the angle. And our calculators have 3 inverse functions to help us find that. It's the sine, the cosine, tangent with the little -1. You hit second and then the function to get those. If the trig function is positive, then it's going to give us acute angles. Now, it gets a little bit more complicated, and we'll get into that more in Chapter 9, but for now, we just want to use it and practice using it and get a little bit familiar with keys. So, you're going to use a calculator to find an angle theta in degrees. Now, you do have to be in degree mode for this. To find the angle where the sine is 0.9677091705. So you'll do second sine, make sure you're in degrees. Do second sine and put that number in. And then for B, make sure you're in radians and do second tangent 0.25. Pause the recording, give these 2 problems a try, and resume to check your answer. Okay, so with degree mode, there we go, got a little picture of it there. You can put that in and you get that the angle for part A is 75.4 degrees. And for part B, we get that the angle is 0.24497866631 radians. And notice for degrees, you do want to put the degree symbol. You don't need any symbol for radians. Okay, now you're going to find all the values of theta if theta is between 0 and 360, and the cosine is -square root of 2 over 2. So you need to think about this. It might help to kind of draw a graph and see where you're going to have negative cosines. Pause the recording, give this a try, and resume to check your answer. All right, since it's negative, the angle has to be either in quadrant 2 or 3. It can't be in 1 because everything's +1, and it can't be in 4 because cosine is positive in 4. So we also know that the square root of 2 over 2 is a 45-degree angle. So what we need to do is we need to find the 2 angles that have a reference angle of 45 degrees. We need the one that's in quadrant 2 and the one that's in quadrant 3. So the one that's in quadrant 3, kind of doing this backwards, you're going to do 180 plus 45, and that gives you 225. And then quadrant 2, you're going to do 180 minus 45, and that gives you 135. Okay, this diagram illustrates the relationship of the right triangle ratio definitions of the trig function to the unit circle. Now it's a little bit crowded and might be a little hard to read. The blue arc, SR, is the first quadrant part of the unit circle. We have an angle POQ, which is where the theta is. That's an angle in standard position. The coordinates of point P are going to be cosine theta, sine theta. And then the 6 trig functions can be interpreted as lengths of the line segments that you find in this diagram. For sine and cosine, we're going to use the triangle POQ that you see there. For tangent and secant, we use VOR. It's a little bigger triangle. It's similar to POQ. For cosecant and cotangent, we use USO. Now, you may be wondering, why are we going to use angle U? Well, angle U and angle theta are alternate interior angles. Okay, the line ST and OR are parallel. So those are 2 alternate interior angles, which means they're equal. So any measurement we find for angle U is going to be the same as the measurement for angle theta. So we can use that triangle. And this is a summary of that. I know it's a little bit of a mess. Look at them one at a time. We've got, the first thing is the cosine of theta. Cosine is adjacent over hypotenuse. Well, adjacent is OQ. Hypotenuse is OP, which is 1, because remember, we're in the unit circle. So it's just OQ. So it's just that x value. The sine is PQ. Again, it's the y value. And again, they're showing you how to get that. The tangent is VR. Okay, it's the side opposite theta, which is going to be VR. And it's over side adjacent to theta, which is OR. Well, OR goes all the way out. That's the radius of the circle. That's 1. So it's just VR. Okay, then we have the secant. The secant is the hypotenuse over the side adjacent to theta. And again, we're going to use that bigger triangle. And the hypotenuse is going to be OV, which we don't know what that is because that extends beyond the unit circle. But we do know OR. Again, that's 1. So the secant is just going to be the line OV. The cosecant is going to be OU. Now remember, for these last two, we're going to use that kind of upside down triangle. The hypotenuse is OU. The side opposite the angle is going to be OS, which is 1. And then the cotangent, we're using the same triangle, and it is opposite over adjacent, or adjacent over opposite, excuse me, and that's going to be US over 1. So, suppose that angle TVU measures 60. We're going to find the lengths of OQ, PQ, VR, OV, OU, and US. Pause the recording, give this a try. Probably be a good idea to copy this drawing and maybe make some notes on it, write on it, and resume when you're ready to check your answer. Okay, so here's our solution, and it would be helpful if you had copied the drawing down so you could see it. Angle TVU has the same measurement as angle OVR because they're vertical, so you can fill that in. So OVR is 60. And because that's one of the acute angles in triangle VOR, then theta has to be 30. And once you know that theta is 30, then you can go through and find all these different measurements. You can label the lines and get all that in there so you see the answers here. Practice. So as you go through, pause the recording, give these problems a try, resume when you're ready to check your answer, and proceed that way through the rest of the recording.